Hey everyone, again, this is Brian Slane with EnGenius Technologies. I'm product line manager for EnGenius, heading up the EnGenius Cloud solution. Today, first, I need to thank Streakway for hosting today's webinar, and I want to thank everyone for joining today. We appreciate your time and your interest. Today's topic is Wi-Fi 6E, Gigabit Wi-Fi, or is it really Gigabit Wi-Fi? I guess we'll try to answer that question today a little bit and talk a little more about a couple things. So what I want to do is cover Wi-Fi 6 as an overview, where we're currently at, get an understanding of Wi-Fi 6, and then what is Wi-Fi 6E? What are the benefits of Wi-Fi 6E? And then EnGenius's Wi-Fi 6E product or our solution offering that will be available at the beginning of June. So let's go ahead and just dive right into it. So let's first talk about Wi-Fi 6. This is basically where we're at today. But before we talk about Wi-Fi 6, we should understand kind of the path, the journey that we took to get to Wi-Fi 6. So there's been various versions since 1999. There's Wi-Fi 1 and Wi-Fi 2, specifically 802.11a and 11b, which were introduced in 1999. 11a operates on 5 gigahertz, and I know everybody loves hearing about theoretical speeds, but it provided up to 54 megabits per second on the 5 gigahertz band. We also had 802.11b, which was introduced in 1999. That actually operated on 2.4 gigahertz, and that offered up to 11 megabits per second. The adoption rate grew faster on 2.4 gigahertz. So that's why early on when we started this journey, that's why we are seeing a lot of devices operating on 2.4 gigahertz. And we're designing around 2.4 gigahertz frequency. And 2003, we introduced, the industry introduced 802.11g, which also operated on 2.4 gigahertz. That also provided up to 54 megabits per second. Now that was a big leap from 11 megabits to 54 megabits. You have to keep in mind that when Wi-Fi was introduced, the adoption rate grew really fast on 2.4 gigahertz, and 5 gigahertz almost got forgot about. It was just easier to implement. It traveled further. You could have great Wi-Fi coverage. So the adoption rate was much faster. I believe, if my memory serves me correctly, it was probably cheaper to implement as well. And then the introduction of 11G got us closer to the speeds of 5 gigahertz. We're still operating in the 2.4 gigahertz frequency band, but gave us greater speeds under 11G. So that was a big leap from 11 megabits to 54 megabits, still operating on 2.4 gigahertz. Now, through that time frame, as a lot of you probably are very aware, that band became very overcrowded. And so there was a new introduction in 2009 of 802.11n, which operated on 2.4 gigahertz and 5 gigahertz. Now that was a major leap in regards to the theoretical speed and actual speed as well, just not as high as 600 megabits. But 54 megabits to 600 megabits was a huge leap, and it also operated on 2.4 gigahertz and 5 gigahertz. So that gave us a greater amount of Wi-Fi to work with. We could work with 2.4 and now 5 gigahertz, and the adoption rate started to really grow in 2009 on the 5 gigahertz side, meaning on the client side. USB adapters were operating on 2.4 and 5 gigahertz. Laptops with mini PCI cards were operating on 2.4 and 5 gigahertz. So the adoption rate really grew, and we started to see speeds that were faster and higher. You know, the attempt has always been trying to achieve the same as wired speed, 100 megabits to a gigabit. Now we're in multi-gig and so on. So we've always been chasing that side of it, the speed realm or the speed side of wireless, and getting faster and faster to be as fast as wired, and also being secure was the other factor, right? So the adoption of 2.4 and 5 really grew. A lot of installers, system integrators understood that on the 5 gigahertz side, there's a lot of there's more channels to choose from, and there's more non-overlapping channels, meaning access points could operate on cleaner channels. You could deploy more access points without them interfering with one another. So there was a huge opportunity with 5 gigahertz, and that's when the adoption grew. Intro into 2013, which was 802.11ac. This only operated on 5 gigahertz. That was another big leap, up to 1.3 gigabits per second with 11ac. So we had two variances of 11ac, actually technically three, but I'll say two. 802.11ac wave 1, and then 802.11ac wave 2. 802.11 wave AC wave 2 introduced some things like multi-user MIMO and a couple other items. But again, this was development on the 5 gigahertz side. Everybody was adopting 5 gigahertz. We understood that the client's best performance would be on 5 gigahertz, and that was the path to take. And so there was more development around 11AC or on 5 gigahertz with 11AC, and improving the speeds of that particular band. Now, as we continued through 802.11ac, 5 gigahertz, 2.4 was already really being overused at that point. 5 gigahertz is also a band that's starting to be used more and more, or used all the time, I should say, and it's getting really loaded with clients. But how do we handle all this traffic? When you go into deployments of maybe 10 access points, 20 access points, typically you don't really run into any issues. But when you run into installing 50, 100, 200, 500 access points in a location or within a network, 5 gigahertz gets really small really quickly, and the number of channels that you can use gets really, really small. And so that non-overlapping channel selection that you have gets smaller and smaller, because now you're doing channelization over a lot of access points. And so it becomes a problem. So introduced in 2019, which was 802.11ax, which really improved the efficiency and the effectiveness of how wireless communicated between client devices and access points and so on. And that operated both on 2.4 gigahertz and 5 gigahertz. So that was a big advantage. This new technology that was able to utilize the band a lot more efficiently on 2.4 and 5 gigahertz, theoretical speeds were up to 10 gigabits per second. So we've been talking about 10 gigabits, gigabit speeds, wireless speeds, since basically 2013. So will Wi-Fi 6E actually give us gigabit speeds? We'll see. So the introduction of 11ax, which was in 2019, EnGenius is, we launched I would say late 2019, and maybe Eddie, maybe he could correct me on that, but that's when we introduced our first 11ax access point, which is a 2x2 solution, and then we went into a 4x4 solution. That solution is being used today, and we use it in every case that we do an install. I would not use Wi-Fi 5 or 11AC in installations today. I would only use 11ax installations or access points in our installations today. So 11ax brings in a lot of capabilities, a lot of benefits. And again, it's operating on 2.4 and 5 gigahertz. Another thing I'd like to note before I move to the next slide is, when we design networks, we design around 5 gigahertz, meaning we're anticipating, or we're designing around the weakest link within the network, which could be or would be like a cell phone, for example, that's operating on 5 gigahertz. 5 gigahertz provides the highest speeds possible within a network, so we design around that. We make sure we have coverage for 5 gigahertz, and we have coverage and roaming capabilities with a small device like an iPhone or a Samsung phone that can roam and operate within the 5 gigahertz frequency without band steering over to like maybe 2.4 gigahertz. So we try to keep everybody at 5 gigahertz, giving them maximum performance within a network. And that's a really key note to understand and to carry this presentation through too as well. So now we're at 11ax. What are the benefits of 11ax? So as I mentioned, we had Wi-Fi 1, which was 11B, Wi-Fi 2, 11A, Wi-Fi 3 is G, 4 is N, 5 is AC, and now we're at Wi-Fi 6. this is the current time frame. Enter in Wi-Fi 6, which is 802.11ax. Here are some of the features and benefits of this particular technology. It's really important to understand. I'm giving you a high-level view of this particular technology and how it works, but one of the big key factors in Wi-Fi 6 today is OFDMA. OFDMA, I won't go into a deep dive in any of these particular points, but I will say OFDMA enables more efficient channel use because we're limited to our channels within 5 gigahertz. Surprisingly, at 2.4, we're definitely limited with channel choices. But OFDMA really enables more efficient channel use. It reduces latency between access points and client devices and provides backwards compatibility with 2.4 and 5 gigahertz. So it's a really key benefit to 802.11ax or Wi-Fi 6. Another big development was 1024 QAM. This really boosts the throughput by 25% over 11AC and provides greater reliability, mainly in short distance communication, which is totally fine because in 5 gigahertz, that spectrum or that wavelength doesn't travel as far as 2.4. So typically the distances are shorter, but it did boost our throughput by 25%. Target wait time, or you might see it as TWT, reduces power consumption. You can actually schedule wake times to IoT devices or cell phones. So it extends the client battery life of mobile and IoT devices. There's another feature called BSS coloring and spatial reuse. BSS coloring tags packets with a particular color to differentiate between adjacent service sets. And it also helps with spatial reuse, which enables simultaneous transmissions on the same channel via BSS coloring. So BSS coloring and spatial reuse work together to provide more efficient communication between multiple SSIDs within close networks. So a huge benefit there. Another one which you've probably heard of is uplink, downlink of multi-user MIMO. You probably first heard this when 11AC was available, specifically Wave 2. This is also introduced into 802.11ax. This really supports, you can support up to 8 clients and provides greater network efficiency with particular clients, and it allows the radio to be focused on specific users and and ensures the optimal signal and reception reliability to an end user. As you're actually physically moving around, the beam will form and shape towards that particular device, making the overall experience much better. Another feature was longer OFDM symbols. This enables shorter wait times between data transmissions, and it tolerates more noise, which allows greater coverage. The really big benefit is, you're getting a little more coverage. You can send packets a little bit further. They're more resilient to interference. But this is also something to think about if you're doing outdoor deployments, maybe with the ECW336 or the specifically the 260, which is a Wi-Fi 6 access point, and outdoor deployments. Soon, Eddie will be launching a point-to-point Wi-Fi 6 solution. So longer OFDMA symbols is a really important feature to really consider. So this is kind of where we're at this is where we're at right now with Wi-Fi 6. These are all the features that are within 802.11ax. These are the features and benefits. So this is our current state. And again, we've installed Wi-Fi 6 for about 3 years now with great success. So some of those success stories were specifically in high density application, meaning a lot of users. So EnGenius and our partners have been able to serve high profile, high density applications. More recently, the Davis Cup. The Davis Cup was a state-of-the-art high-density arena in Spain. This particular event had about 12,000 attendees, and we served that community or those attendees with a Wi-Fi 6 solution. We also worked with a multiple education institutions, but specifically and more recently, St. Thomas College. This is a college that had just an assortment of network devices, and they were looking for a more high performing network. They updated their ISP connection to a higher rate, bandwidth rate, and so they wanted to be able to deliver that faster speeds to their students, to their staff, which is approximately about 2,000 plus students and staff, and they also use Wi-Fi 6 in this particular application as well. Earlier in the year, when we first launched our Wi-Fi 6, we were lucky enough to support Taipei, which is in Taiwan, a huge countdown party for New Year's Eve, which had about 20,000 attendees. We also used Wi-Fi 6 access points in this deployment to support all those users. So Wi-Fi 6 is being utilized in pretty much every situation that we go into today. The technology works really, really well for, we've installed it from home to residential, all the way up to large events like Davis Cup, Thomas College, St. Thomas College, I should say, and the Taipei New Year's Eve celebration. So you can really take advantage of this newer technology. It's way more efficient, provides higher performance across a lot of users. So some really great benefits with Wi-Fi 6. So this brings us up to the current point, which is what is Wi-Fi 6E or Wi-Fi 6? Wi-Fi 6E is an extension of Wi-Fi 6. You're basically combining, it's basically the combination of the higher efficiency wireless protocol of Wi-Fi 6 now in a super wide frequency band, which will be a game changer for the Wi-Fi industry. It's really changing a lot of things for the Wi-Fi industry in a very large way. You may be aware, you may not be aware, but hopefully as we work through this, you can visualize this and you can see this as we talk about it. So again, it's a combination of what we just talked about, those higher efficiencies where we're using Wi-Fi 6 and all these different applications with high density applications, with very large applications running. And now we're putting this technology, this protocol, in a new super wide frequency band. So just to give you a brief understanding of how Wi-Fi 6E came about, in early 2020, the FCC made 1,200 megahertz of spectrum available for unlicensed band in 6 gigahertz. So 6 gigahertz, the spectrum, offers double the channels that 2.4 and 5 gigahertz offers combined. So again, I should repeat that. 6 gigahertz spectrum offers double the channels that 2.4 gigahertz offers and 5 gigabit offers. So in late 2020, the Wi-Fi Alliance jumped on this immediately and announced Wi-Fi 6E as an extension to Wi-Fi 6. Wi-Fi 6 is the technology we just talked about with all those benefits. So this technology will work in 6 gigahertz. So 6 gigahertz devices, anything new coming out with 6 gigahertz, will use Wi-Fi 6, the technology, to operate in this new band. So this is a big portion of Wi-Fi 6, and there's a lot of importance around Wi-Fi 6E. So just to give you a visual idea, so 2.4 and 5 gigahertz, this is the channels and the bands or the frequency we have available to us today. And we have Wi-Fi 6E, which is this 6 gigahertz band. You can see how large this is. So Wi-Fi 6E alleviates problems of network congestion, solves challenges related to crowded offices. It improves the responsiveness of cloud and collaboration applications, and allows teams to enjoy much faster speeds when sharing, backing up, and even updating files. It supports larger bandwidth loads. It processes faster multi-gigabit data, achieves lower latency, provides reliable and secure connections. It also will meet new demands for larger bandwidth, real-time kind of mass transmissions required by like augmented reality, virtual reality, and even metaverse applications. So a very large area that we're adding into the Wi-Fi mix. So now we have 2.4, 5 gigahertz, and 6 gigahertz to work in regards to Wi-Fi. Now I was thinking about this earlier, and Eddie and myself, and even Peter, who's also on this call. Peter's our field applications engineer for EnGenius, and also Eddie Lee is a senior product line manager along with myself. We've worked in 2.4 and 5 gigahertz for probably 20 years. We've installed literally thousands of networks operating in 2.4 and 5 gigahertz. Millions of devices are operating in 2.4 and 5 gigahertz. Now there's the introduction of 6 gigahertz. So if we could do those 20 years within these two frequencies, imagine what we can do in 6 gigahertz. There's a ton that we can do within 6 gigahertz. The one thing I would really want to highlight, which it's indicated at the bottom, is that 6 gigahertz provides 60 channels, 29 40 megahertz channels, 14 80 megahertz channels, and 7 160 megahertz channels. Now, the beauty of this is when you had 11AC and Wi-Fi 6 for that matter, you're typically not designing any networks with 160 megahertz unless you're in a residential space and there's no interference, you're in a rural area, you might be able to get away with 160 megahertz. Typically, you never design a network, a business network with 160. You don't even design it with 80 megahertz. Again, you might be able to get away with 80 megahertz, which offers 6 channels within maybe a residential space with very little, maybe not necessarily rural, but your neighbors are not too close together. But you could probably get away with 80 megahertz operating in a residential space. When you get into businesses, when you're getting at 5 access point, 10, 20, 30, 50, 100, never will you provide 80 megahertz. And you'll be lucky to use 40 megahertz because you'll have co-channel interference with your access points. There are installations of 40 megahertz, I would say even up to 50, maybe 50 access points, but Eddie, Peter, you might comment on that. But it's very tough to get away with 40 megahertz in large networks. Currently, we worked on a project where there was about 600 access points operating on 5 gigahertz, obviously. We designed it around 20 megahertz. That was the best that we could do because we had so many access points that were neighboring with one another. We had to channelize those access points to make sure there was no co-channel interference. So this is today's channel selection and the channel width selection. Moving forward with Wi-Fi 6E, look at the major differences. 760 megahertz channels. I'll give you an idea. In our office at EnGenius Technologies in Costa Mesa, California, we have 5 access points. 5 access points covers about 10,000 square feet. We're operating on, I believe, we're operating on 40 megahertz wide channels. Our network is rock solid and delivers really fast speeds to our customers, or to our, I shouldn't say customers, to our users. It works really, really well. Now, with that same building, with 5 access points, I could potentially use 160 megahertz with the 7 channels that I have, potentially. That would be something that we would look into trying to do. In a 10,000 square foot building with minimal interference with neighboring buildings, I could get away with 160 megahertz channels. And if I can't get away with 160 megahertz channels, I can now use 80 megahertz channels easily without any co-channel interference on Wi-Fi 6 or 6 gigahertz, which is astounding. The amount of speed that you can get with 80 megahertz or even 160 is just great. And we'll talk about that a little more. And I'm kind of pausing on this because I want you to see the differences between 2.45 and 6 gigahertz. It's such a dramatic improvement of what we currently have and where we're headed. And this is the other thing I would mention is, what is the question that Eddie, Peter, and myself get a lot? What is the range? What is the range going to be with 6 gigahertz? We get a lot of questions around 5 gigahertz and, obviously the question with 2.4 gigahertz. Obviously the wavelength, excuse me, for 2.4 gigahertz, it's actually a long wavelength. It's about 5 inches or 12 centimeters. That wavelength will travel really, really far. So the range for 2.4 gigahertz is really far. it can penetrate through more obstacles like walls and trees and things like that. It's more resilient in that regard. It can travel further. Whereas 5 gigahertz, where now we have a lot of experience with 5 gigahertz, that wavelength is a little bit shorter, or a lot shorter. It's about cut in half, about 5 centimeters or about 2 inches. So what that means is you get less range. You're still able to penetrate, but you can't penetrate as many obstacles. So again, that's 5 centimeters, about 2 inches long, that wavelength. So just to give you an idea, every installation we do with access points, we design around 5 gigahertz. So a majority of the networks out there have maybe a number of access points like 5, 10, 20, 100, whatever it may be, but they've been designed around 5 gigahertz. What that means is that I want to make sure my clients can roam from one access point to another access point and stay on the 5 gigahertz band and never steer to 2.4. I want to keep everybody on 5. And the reason I bring this up is because all these networks have been designed around 5 gigahertz. Even other vendors or CWNEs, they design around 5 gigahertz because that's the best experience your clients will have if they operate on 5 gigahertz. The reason I bring this up is because I want to talk about the 6 gigahertz wavelength. The 6 gigahertz wavelength is about 4.5 centimeters or almost 2 inches. So it's not very different than 5 gigahertz. So 5 gigahertz, you have about 5.5 centimeters long, whereas 6 gigahertz, you have about 4.5 centimeters long. So the difference in wavelength is not that different. So what does that mean at the end of the day? That means all those networks that have 5 gigahertz or have been designed around 5 gigahertz, you can maybe go in, or you could possibly go in with a 6 gigahertz access point and basically rip and replace with 6 gigahertz, leaving them in the same area. Now, I need to proceed with caution. You always want to do a site survey. You want to use our site survey planner, or you want to go on site and do a planner with like Ekahau, for example. You always want to do your due diligence. But what I'm saying is 6 gigahertz, the wavelength is similar to 5 gigahertz and should travel similar to what 5 gigahertz already has shown us. The major benefit of staying on 6 gigahertz is you'll get a faster, higher, consistent speed. So Eddie, Peter, any input in regards to that? Any note?
Not for me, Brian.
Okay, no problem.
Same here.
So really exciting stuff with Wi-Fi 6E. So let's talk about some of the benefits. I mean, when I look at that last graph, that tells me all the benefits right there, and all the channel possibilities that you have. Operating on 80 megahertz, 100, even 40 megahertz in these large networks is a major benefit. But just to sum it up, so Wi-Fi 6 provides greater capacity. So the 6 gigahertz spectrum is more than double than 2.4 and 5 gigahertz spectrums combined. It's actually providing 7 brand new 160 megahertz wide channels. So that's crazy to me. That's insane to me. I've operated in 2.4 and 5 gigahertz for so long. To be able to provide 160 megahertz, not on every network, but in some, is something very special. It's more efficient. So 6 gigahertz traffic will benefit from the spectrum management and efficiencies of Wi-Fi 6. So it's free from interference. Currently, it's free from interference. And it's free from interference from 2 decades of legacy devices like 2.4 and 5 gigahertz. You'll see there will be 2 onboarding processes that will be used when using Wi-Fi 6E. When you onboard your client devices, your newer client devices like my laptop actually operates on 2.4, 5, and 6 gigahertz. When I onboard onto an access point, I will actually onboard on the 5 gigahertz and it will transition me over to 6 gigahertz. So all of my probing will happen on 5 gigahertz. So I won't disrupt the 6 gigahertz frequency band. So there's less interference, or you won't see like high channel utilization on 6 gigahertz like you do on 5 gigahertz and 2.4, because your probing happens on 5 gigahertz. That's one method. The other method is I have a 6 gigabit or 6 gigahertz client device. It will directly onboard me to 6 gigahertz directly. So some really nice improvements there. It also will provide higher performance. So multi-gig speeds we project and ultra low latencies are perfect for gaming, augmented virtual reality, robotics, and other latency sensitive applications. So big deal with Wi-Fi 6E. So can you use 6 gigahertz today? So I would argue yes, definitely you can. The client adoption is growing. 20% of Wi-Fi 6 devices will support 6 gigahertz by 2022. That's a big deal. Wi-Fi 6 and Wi-Fi 6E will reach 43 billion by 2028. The projection's really aggressive. I believe it's higher than just Wi-Fi 6. More than 338 million Wi-Fi 6E devices entered the space in 2021. Some examples of client devices that are offering 6 gigahertz or Wi-Fi 6E. There's a number of Dell laptops, Lenovo laptops. You have the Samsung Galaxy S21. You even have the Google Pixel 6 and the Pixel Pro offer 6E. And then there's the Intel AX210 that you can actually purchase on Amazon. I've even seen it on eBay. But the Intel AX210 is a Wi-Fi 6E adapter. You can buy for like $35, ranges anywhere from $35 to $50. I'm actually running that particular Intel card in my Lenovo laptop. So I do have access to Wi-Fi 6E. But you can buy this online and you can put this into your laptop, or you can put it into your desktop, no problem. So the adoption of Wi-Fi 6E is definitely growing, and it looks like it's growing at a more rapid rate than what we saw with Wi-Fi 6. So just to give you some input there. Another reason you should potentially use 6 gigahertz is access point to access point communication, meaning meshing specifically, not repeating, but meshing. Meshing on 6 gigahertz band it puts the backhaul basically on a clear channel or clear frequency band, so there's no interference, and you will see high bandwidth on the backhaul connection. So when you're communicating from one access point to another access point, you have this high bandwidth or high link speeds between the access points that are meshing. So even 2.4 and 5 gigahertz devices that connect to the access point can be backhauled on 6 gigahertz to the other access point that is maybe wired to the network. So they can also utilize that backhaul link on 6 gigahertz. So even 2.4 and 5 gigahertz can utilize the backhaul or the communication between the access points that are operating on 6 gigahertz. So these are really two good reasons to use 6 gigahertz today. So just to give you some more insight into that. So let's talk about EnGenius's Wi-Fi 6E product solution. And that's specifically the ECW336. So this is a cloud-managed Wi-Fi 6E access point. This particular access point, it looks very similar to the ECW230, looks very similar to the EWS357 AP. This is a front and back picture. The mounting brackets are similar to this particular device. It's a Wi-Fi 6E, so it's a tri-band. So it's going to operate on 2.4 gigahertz. It's going to operate on 5 gigahertz. It will operate on 6 gigahertz. It's a Qualcomm quad-core CPU setup. We have direct relationships with Qualcomm, and we've had that relationship, and most of our access points have the Qualcomm chip in it. This is the newest version of their CPU, so this is operating on this ECW336. On 2.4 gigahertz, the theoretical speeds are 1.1 gigabit. On 5 gigahertz, 2.4 gigahertz or gigabits, and on 6 gigahertz, 4.8 gigabit. So there are theoretical speeds. As I go down, we'll talk about actual speeds. This is a 4x4 antenna design. So across the board on 2.4, 5 gigahertz, and 6 gigahertz, a 4x4 setup. The Ethernet port is 5 gigabit Ethernet. You might question, do I need 5 gigabit? I would say yes, you do now. With Wi-Fi 6, not necessarily. It's a PoE plus, so it's 802.3 AT compliant. It will work with any PoE switch that is out there. Well, I should say any available switch that's out there. EnGenius has available switches, by the way. So it's 802.3 AT compliant. The radio power for the three different radios is 23 dBm. Typically, when you go into different applications, your output power set to like 17 dBm on 5 gigahertz. You can start off with auto and then adjust from there if you need to. The antennas are on 2.4, you have a 5 dBi, 5 gigahertz, you have a 6 dBi, and on 6 gigahertz, you have a 5 dBi antenna. These are obviously, maybe not obviously, they're FCC approved, CE approved, and NICE compliance. These devices have a 2-year warranty. The MSRP is $699 for this particular device. So let's talk about some of the lab testing we've done with the ECW336 in a couple different scenarios. So we tested really 2 major clients and then even tested in mesh mode. So the Intel AX210, which is in my laptop, you can buy this, like I said, for about $35 to $50. It's a 2x2 spatial stream. It can operate on 5 gigahertz. We tested on 5 gigahertz and 6 gigahertz. It's not channel bandwidth, it's channel width. This is a typo, and I apologize for that. We tested on 80 megahertz. Okay, so transmit and receive throughput, I'll just round up. So about 800 megabits per second on transmit. Again, this is to a client device, 2x2 design, 5 gigahertz. On 6 gigahertz, we saw about 950 in regards to speed. This is lab testing. This is relatively close from the client to the AP, just to be aware. Now, when we move to 80, you can see the big jump in transmit power, or excuse me, transmit and receive speeds. When we tested with Samsung, 2x2, 5 gigahertz, 6 gigahertz, 80 megahertz wide, we're in gigabit or close to gigabit. We're just getting to a gigabit, about 920, somewhere around there. On 5 gigahertz, even on 6 gigahertz, we saw like 930, about 930. So not a major difference with this particular device. Now, mesh mode, a 4x4 access point communicating to another 4x4 access point on 5 gigahertz using 80 megahertz, 1.6 to 1.7, somewhere around there in regards, that's gigabit, basically. When we went to 6 gigahertz, 2.1 gigabits of speed. That's a mesh to mesh configuration. So the backhaul is pretty amazing when you're calling from 4x4 to 4x4. Obviously, when you go 4x4 to 2x2, your speeds will, they'll go down because you have less antennas to communicate. Now, testing on 160 megahertz wide. Remember, we talked about this. With 6 gigahertz, you have, again, 14 80 megahertz wide channels. 160 megahertz, you have 7 channels to choose from. The Intel AX210 on 5 gigahertz, we saw about 1.4, 1.5 throughput. On 6 gigahertz, we saw 1.6 to 1.8, somewhere around there. So a lot of throughput. That's 1.6 gig to 1.8 gig. The Samsung 160 megahertz wide channels, 1.4 on the 5 and 1.7 to 1.6 throughput on the Samsung. Now in mesh mode, this is ridiculous to me. On a 4x4, 5 gigahertz, 1.6, about 1.6, 1.7 throughput on the backhaul speed, so point to point or mesh node to mesh node. On 6 gigahertz, 3 gigabit of backhaul speed. That's amazing to me. So, you tend to want to limit your hops because you're cutting your speed from 40 to 60%, somewhere around there. I don't know if we've tested multiple hops on this particular device, but that's one of the plans in test, and we'll provide those results. But the speed is pretty ridiculous. This is lab testing, so relatively close testing. So our FAE, Peter did some field testing. So we tested the ECW336 access point with our brand new ECS2528FP multi-gigabit switch. It's a 24 multi-gig switch. The PC was running Windows 11. There is issues with Windows 10. You have to do some reg edits for it to work with Windows 10 and a Wi-Fi 6 E device. So we would suggest using Windows 11. The card we used was the AX210 client. Again, you can buy that fairly cheaply off Amazon, or Streakwave may offer them. I'm not even sure, quite honestly, but this particular client device, we were operating on 160 megahertz. We used channel 5, transmit power set to auto. We did use WPA3 personal. Client link speed negotiated at 2.4 gigabit. Actual speeds we tested were 1.1 to 1.4 gigabits per second. And Peter, if you could chime in on your testing and kind of the testing setup. I know you did some distance setting outdoors with clear line of sight, excuse me, and then some interior testing across multiple walls. So if you could add some more information into that, that'd be great.
Oh, sure thing. So yeah, so hello everybody. So yeah, so the field test that I did in the lab that I performed, like Brian was mentioned, we had one client device that was outdated, and we updated it with a Wi-Fi 6E card, and then we had a native laptop that came with that, so we were able to do two type of clients. We used iPerf to do the test, and we did a 3 feet test, 10 feet test, and we did one up to 90 feet test, line of sight. And the speed was, like he says, ridiculous. It was really fast. We've been doing a lot of wireless testing on the 5 gigs, but this is off the charts. Like it's really fast, and it was very consistent. So
Yeah. So you mentioned to me that you did some when you did interior testing, you went through multiple walls. Can you kind of talk about that a little bit, or give a little more insight into that? How many walls? What was the speed at that point? If you need to do additional testing, that's fine too. You don't have to share, but just if do you have any insight there, or provide any information? If not, that's okay.
Oh, definitely. Yes. So the other test was going through walls. The lab and the place where I set up the wireless client was actually 4 rooms of separation. So there's 1, 2, 3, 4 walls, and we didn't see that much of loss in speed. It was very minimal. So I do have the screenshots, but yeah, it was very
So
very.
was it in the gigabit, or is it just under gigabit? What was kind of the average speeds you were kind of seeing?
Oh, it was above gigabit. Yes, it
Oh,
was.
nice. Okay.
Yeah, it was around 1.17. I think that was the number. Yep.
Okay. Perfect. Okay. Great.
Hmm.
Eddie, any experience that you can share, or not? Not at this point.
Yeah, Brian, something I want to add to the test Peter was conduct. He down to like 90 feet, right? And we do many tests, and we see consistently like a consistent speed like 1.3 average. We didn't see like drop dramatically, but sometimes it's 1.2, sometimes 1.4, but the average speed for the 90 feet is like 1.3 gigabit. So it's pretty amazing, like with outdoor clear life site, and also with a long distance, not too long, but 90 feet. Yeah, we got pretty good speed in terms of throughput. So
Yeah, I think one of the things that amazed me is that, when we first started talking about 6 gigahertz, the big question was like the range. How good is the range going to be? And, you really we really couldn't say for sure, like if the range was going to be, that great or not. And so far, the testing that we're doing, it's really good. So again, I would reiterate, it's kind of like our scenario. So our office is about 10,000 square feet. Currently, we're running Wi-Fi 6 access points, every one of our clients, maybe except for maybe one or two, are operating on 5 gigahertz. Everybody already knows that 5 gigahertz travels less distance. The thing I was trying to mention before is that 6 gigahertz will have similar traits to 5 gigahertz in regards to range. It definitely, I think it will be shorter, but not that much shorter. We might be in a position where in our office, it could be different for in environments, is that we rip and replace all our Wi-Fi 6 access points with Wi-Fi 6E access points, and there's no change or addition of access points. So that to me was a surprise, and that's what we're kind of seeing with other CWNE reports and things like that, and testing that I'm seeing as well. So the wavelength on 6 gigahertz and 5 gigahertz are pretty similar. So that's really surprising to me, and that's exciting to me. So if you're deploying 5 or you're designing around 5 gigahertz, just imagine the projects that you've done in the past and that you could potentially replace with 6 gigahertz, but now you're providing this tremendous speed. I would also mention that every one of those access points in our office, the 5 that are covering 10,000 square feet, you could easily mesh those access points together. I wouldn't have that many hops, but the potential is there to be able to mesh some of those units and not run wire. And to be able to provide that kind of link speed is, I mean, it's going beyond, well, it's definitely going beyond Cat 5e, but it's going beyond like gigabits wired speed, right? So, okay, great. Thank you very much, Peter and Eddie, for adding that additional information. Okay, with that said, I'll open it up for any questions that you may have. So Angela, whenever you're ready with questions, I'll try to answer those questions as much as possible.
Yep, sounds good. I do have a couple here, so here we go. Could you speak to how 6E allows for higher power output as the channels go wider, unlike all other Wi-Fi versions that lower the power with wider channels lowering the SNR?
Oh, that's a great question. So there is a technique, and I can't put my finger on I can't remember the acronym, but it does. So as you add wider channels within there's some techniques that will make an adjustment. Okay, let me start here. As you know, SNR is a variable, right? And so it changes as you change. When you go to wider channel widths, the SNR could potentially go down. And so you want to have really good SNR. So there's some techniques with Wi-Fi 6E where the ratio, when you change the channel width, the ratio makes the SNR, you bump up the power basically as you change the channel width. I think that's what I read or understood it to be, but there's some adjustments there. So that's as much as I know about it, but there's been improvements around that where SNR was a variable before. Now it's written into when operating on 6 gigahertz to give you better results. So it will adjust the output power based off of what your changes are with the channel width. So we should see improvements or adjustments there that will help us have better SNR as we move through in configuring installations. That's my rough answer to that very good question.
Not a problem. Next question I have is, will you guys have an outdoor unit?
There are plans for an outdoor cloud managed access point with 6E. We definitely want to get this first unit out, which will be available June, the beginning of June. So there will be one on the roadmap. I couldn't provide additional information on that.
Got it. Next question here, is this a Ptmp device or a mesh device? And will this also work on the 6 gigahertz spectrum?
Oh yeah, this particular access point, it's not meant for point to point or point to multi-point, but it could it could kind of operate that way. You're technically you're doing that when you're meshing. You're basically providing a point-to-point, point-to-multipoint, but I wouldn't use this specifically for a outdoor point-to-point or a point-to-multipoint. You could utilize it that way, but you're using mesh mode to be able to do that. You can't remove the antennas. It's a built-in antenna. So, you know, you wouldn't necessarily use it in that manner. But yeah, it's obviously operating on 6 gigahertz.
Awesome. Does the ECW336 support beamforming? And does it matter if the AP is mounted on the ceiling or on a wall?
It definitely does matter how you mount it. The integrated antenna is an omnidirectional antenna. It does have beamforming. All of our Wi-Fi 6 and Wi-Fi 6E devices will have the beamforming technology as well. So yes, it will have that. But it does, in regards to the radio patterns, which are on the spec sheet, it will matter how you place that antenna. It was designed to be a ceiling mount access point, and even the height, I would be cautious of the height. You know, we get a lot of requests for warehouse deployments where the ceilings are, 20 plus feet. You have to be really careful. I wouldn't go beyond a 12 foot, 12, 13 foot height ceiling. They can go on the walls. We have them operating on walls in several scenarios. It just depends on the coverage area, but if it's in a room, the immediate people in the room, no issues whatsoever. If you're trying to go over multiple rooms, then maybe the third room is going to have some sort of difficulty, but it operates pretty well in regards on the wall and on the ceiling.
Great. Here's another question. This individual says that they've heard of out-of-band scanning with 6E, where it can see 5 gigahertz radios. Have you heard of this as well?
Yeah, in fact, that was kind of what I mentioned prior, is that the client devices that will be coming out, or the client devices that are coming out and are out, operate on 2.4, 5, and 6. Those devices can actually, there's two ways of jumping onto our access point, the ECW336. You can either take the way of connecting via 2.4 or 5 gigahertz, and it will route you to or move you to 6 gigahertz. So that's one method. The other method is directly connecting to 6 gigahertz right away. So say, for example, I'm doing the installation and I know all my clients are 6 gigahertz. I'm only going to enable the 6 gigahertz radio to broadcast the SSID. Client devices will be able to associate to that SSID, no problem. Now, if it's a mix of devices, legacy devices and tri-band client devices that are operating on 2.4, 5 gigahertz, and 6 gigahertz, they will onboard on 5 gigahertz. They'll probe the 5 gigahertz, for example, and then the access point will put them on 6 gigahertz, and they're operating on 6 gigahertz. But that's what I was saying before. The client devices will probe on 5 gigahertz and then move them to the 6 gigahertz channel, and then they'll operate on 6 gigahertz.
Great. Does EnGenius have any Ptmp devices?
Oh yeah, we have several point-to-point, point-to-multipoint. I think that's what they're referencing. Mainly an 11AC Wave 2. We'll be launching a Wi-Fi 6 point-to-point solution here shortly. That falls under Eddie's line. Maybe Eddie can speak to that a little more, but yeah, we will have a Wi-Fi 6, 5. I believe it's operating on 5 gigahertz point-to-point solution coming very soon. I think, right, Eddie?
Yes, so the Wi-Fi 6 point-to-point we're going to launch in Q3 and probably mid Q3 to end Q3 timeframe. But speaking of the Wi-Fi 6E, we do have is in our roadmap for the point-to-point and multiple point solution as well. So I will keep you guys updated when time comes. So.
And just really quick, Angela, I wanted to kind of circle back really quick in regards to the question about SNR and when you widen the channel width. So every time I'm looking at my notes, every time you double the channel size, the EIRP also increases. So Like the noise, say for example, noise floor rises 3 dBm. When you widen the channel, the EIRP also rises 3 dBm. The EIRP that stays at the same level and the SNR stays constant rather it being a variable. So just wanted to get a little more information about that. But I thought that was also a huge benefit into what we're seeing with the developments of 6 gigahertz and just in general. So
Great, thank you for that.
Yep.
Is there an expected availability date for the outdoor equipment?
Oh, I wouldn't be able to provide. I think in reference to 6E, I couldn't provide that. If you're talking about Wi-Fi 6 just in general, not 6E, then that's based off of what Eddie's information.
Okay. And then lastly, we have, will these have a yearly service license? And if so, what is the cost?
No, so there's two methods in regards to the management solution that we offer. I would say 90%, maybe 85 to 90% of the management solution is license free. If you're using some pro features, more advanced features like VLAN pooling or BCMC suppression or client timeline, they fall under like a pro or a license. The ECW336 which is the tri-band Wi-Fi 6E access point. All the functionality will fall under the license-free model, no problem, unless you're looking for more advanced features which apply to all access points. It doesn't just apply to the ECW336. So you can buy that access point today and manage it with cloud, free account, no problem, and you're good to go.
Awesome. And one more question just snuck in. Is there a limit to how many access points a cloud controller can support as opposed to an on-premise controller?
Can you repeat that one more time? Sorry.
Sure. Is there a limit to how many access points a cloud controller can support as opposed to an on-premise controller?
Well, I would say with the cloud management interface, it's pretty much limitless. So you can, under any account, if you create an account today, you could manage up to 100,000 devices, and 100,000 devices could be all access points, it could be all switches, or it could be a mixture, but 100,000 devices. So if any of you have an application for that, please contact me immediately. I'll help you execute. But yeah, it's pretty limitless. On premise, if you're going with like the Sky Key, it's up to 100 devices. Even some of our EWS switches support up to 50 APs. If you take our management software and put it on like an AWS server or put it on your own server, it's going to be limited to the resources of that server. So if you are putting it on a very old server, you're going to be limited to that old server. If you put it on a new server with new CPU, tons of memory, you're going to be able to manage more devices. But so on-premise can be flexible, but you're limited to your server or what you're paying for it with AWS. Versus cloud, up to 100,000 devices, you could do it on a license-free system, basically, for that. So.
Awesome. Well, that was all the questions. So thanks all the attendees for attending today, and Brian for doing the presentation, as well as Eddie and Peter chiming in as well. So everybody, again, this webinar has been recorded, and a link will be shared with everybody, and I'll post it on our YouTube channel and EnGenius's product page on our streetwavewireless.com website. So again, thanks everybody, and Brian and in the EnGenius team.
Thank you.
Thank you.
Thank you.